Hello everyone, today I will introduce the content of week 2 for the course, Artificial Intelligence for Earth Observation. The aim of the session is to introduce the AI in ML, which includes a review of the previous week's material and an introduction to the basic concepts of artificial intelligence and machine learning, along with their application in Earth observation. Last week, we learned about the application of AI in Earth observation, including 3 examples, Sample 1, Sample 2, and Sample 3. However, in practical application, manually selecting data, so helpful for understanding problems, often lacks accuracy. This leads to the necessity of the machine learning method. Next is an introduction to AI and ML. What exactly are AI and machine learning? So, simply put, machine learning is a subfield of artificial intelligence that enables computers to learn from data and make predictions or decisions without being programmed. The key to the machine learning is that algorithms can continuously improve themselves through experience, enhancing the model performance. Here is the full process of the machine learning. It involves some key steps. The first one is problem definition, data collection, data processing, feature selection and engineering, model selection and training, model evaluation, and model optimization. The first one gonna be definition. It is clearly define the task and goals to guide the entire process. The data collection is to obtain high quality data, as the diversity and accuracy of the data determine the model performance. Then it's the processing. It's clean the data, handle missing values, and ensure the data format is correct. The first one, selection and engineering. Select the key attributes to improve the predictive capabilities. Then model selection, choose an appropriate algorithm based on the problem type and train model. The model evaluation use metrics such as accuracy, the precision, and recall to measure the performance. Then the last one going to be optimization. Adjust the hyperparameters, optimize features, or use a different algorithm to enhance the performance. On the fifth slide, we'll discuss about the classification of machine learning. It can be classified based on task types and learning methods. By the task type, the regression is predict the continuous value, such as a temperature forecasting. Then the classification is to predict discrete categories, such as classifying the CIs and leads. For the learning methods, it has like unsupervised learning, supervised learning, reinforcement learning. So for the unsupervised, it's use the unlabeled data, where the model identifies the patterns, and this one is trained on labeled data. And for this one, is optimized strategies through the rewards, such as in the robotic control. And for the problems, we may encounter underfitting and overfitting. Underfitting is like you can see from the blue spots, but we only get the red line. Means the result is too simple, or the model is too simple to capture important patterns. And overfitting is different one is the model overlearns the training data, resulting in poor generalization ability. Next is introduction of CIs and the lead classification, which involves data processing. The problem definition is to use the machine learning methods to classify the CIs and leads. The data collection use open source data from the OSAI datasets, then processing from, it's like changing the format from NetCDF4 to MPY. We select a region of interest to ensure data validity, mark target areas using a mask, and consider both individual data points and surrounding environment. This one is like the data points, and it's the surrounding environmental factor during the training. It allows the model to learn more comprehensive features. So training and testing, the ratio gonna be 9-1. It's 90% is for the training and 10% for testing. And the saving features and labels store processed data for the model input to facilitate the subsequent training. With these steps, the data processing phase is complete. Next is application of machine learning method in this example. So during the model training phase, we tried the following method, which is CNN, random forest, and VIT transformer. Just call it VIT. It's the coding in Python. So for the CNN, it's like for the excellent for image recognition and data analysis. And for this one is it's a nice method suitable for the structured data classification. And for VIT, it's a deep learning model based on self-attention mechanism, performing well on large-scale image data. And 1, 2, 3. The three are the results by using different method. So we can know that by using CNN, it's the best method in this case. So in terms of model evaluation, we use cross validation, which helps identify optimal model hyperparameters and improve generalization. Additionally, during this process, we can adjust the parameters and optimize features and even adopt more suitable algorithm to enhance the classification accuracy. So the next slide is about the model optimization. Of course, it's not the part of the current task. It's often the most complex and challenging part of a project. I'll continue learning about it in the future. I hope everyone has been a clear understanding of the AI application in Earth observation. Thank you for listening.